So my original plan was to try today with this presentation on classes to actually make sure we get through as much as possible through the presentation as opposed to just keep coding. But we'll see. Sometimes it doesn't work exactly that way. So I think we stopped on this slide where we mentioned that at design time, before you write any code, it may be a wise thing, especially if you're working with object-oriented programming environment, to actually think about your program before you write it and formalize your knowledge about formalize your thinking in a form of UML diagram. The minimal version of a UML class diagram would be a box with the name of the class, with the section that is describing data attributes, and a section which describes a set of methods being used by the class. We, of course, do a lot more work and still will continue to do a lot more work with UML in CIS 123. But at least for those who's not taking CIS 123, I would strongly recommend taking a look at the recordings we're posting for that class as well, and just be aware that in real life, no programs written today, any non-trivial software is written today without some sort of planning and designing and visualizing before you write any code. The challenge with those diagrams, of course, is that once you start coding, you discover things, you change things, you take alternative decisions, and some of those UML diagrams can no longer be true, can no longer be reflecting what you're actually doing in your code. And that is a challenge, and oftentimes it's also your responsibility to go back and update those diagrams, or go and find person responsible for maintaining those diagrams in good shape and let them know. But oftentimes knowing that typically things change, technical writers responsible for keeping the documentation oftentimes will go around and interview you in terms of what changes took place. So anyway, but we just kind of briefly mention all this here, but it's much more of a conversation and talk in CIS 123. So I'd encourage you to keep track of what's going on in CIS 123. All video notes are posted there. Unified modeling language is de facto a standard for modeling. Other types of modeling are also available. Some people try and experiment with other diagramming tools and notations, and that's wonderful because we want innovation. But UML is de facto is the standard that industry widely accepts as the description of formal design in your projects. So I am not going to dwell on a lot of details about this, but the book mentions it, and a good portion of CIS 123 is dedicated solely to UML. One note about UML is that its notation is somewhat different compared to Java. So private and public become pluses and minuses. Method names appear before the return value, return type in this notation, and so similar things apply also to method parameters. But sometimes it's easier to look at this table rather than staring at the code with a lot of methods coded in them. So We mentioned that we can have instance variables. Instance variables are variables that are simply part of the object. Once the object is created, each instance variable becomes part of that object. By good design rules, they should be made private. The constructor of the class is, of course, the method that gets invoked once the object is created by the new operator. But it should be noted that we do not explicitly call constructor methods. We say that the execution environment makes a call for us. We tell it to say, we say new, let's create a new object. And part of the new is to allocate memory and then call the constructor. And it's true in Java and in C++, the same thing. When objects are created, we do not explicitly make calls to constructors. Once object already exists in memory, you cannot call its constructor anymore. The only situation where you get somewhat close to secondary constructor work when you make a copy of your object. Then you could write a copy constructor, which takes place in that situation. But rather than that, constructors are just straight for creating new objects, and we do not call them. They're invoked for us. That's what programmers kind of like to say. Getter and setter methods are simply methods providing access to individual pieces of our object, individual data members, because typically those are made private. But typically a lot of those pieces of data still need to be accessible outside of the class. And for that reason, you can add getters and setters, those types of methods. Some environments can automatically generate them for you. You just sort of like code your data attributes and go to a menu and say generate getters and setters. That can be useful, but I prefer to code mine by hand so that unless absolutely necessary, I'm not going to code those methods in my class. But you would expect them to be present for all data attributes which supposed to be accessible from outside of your class. The question is, why not make those data attributes public, right? So why is it a good design decision to keep them private? Well, first of all, it gives a class that we're trying to design a chance to control its own state. After all, if you make those data attributes public, you're no longer controlling the state of your object. Anybody could then go outside of your class, create object of your class, and then start modifying data attributes, those variables in instance variables inside your object without you knowing it, without you controlling it. However, if they're using getter and setter methods that you provided, then you're still staying in control. For example, it may be that I may decide that part of set code product, I also want to be able to update the price without the user, the client of my class, knowing it. It's a possibility. If I made this code public and allow someone to go ahead and modify it, then there is no simple way for me to control it. There's no way for me to control it, because if I want to part of set code, I also want to adjust the price, then it's not possible if I made this data attribute public. Because if I did make it private, then I'm forcing anyone to call this method. And once they call this method, now I am in control. I am in complete control of what's going on, how do I update the code, and what I do with the rest of it, right? And even though this looks trivial, just saying, look, there's just one line of work which could be done outside if the code attribute was made public. This is just pretty much the only way to go. It's part of the encapsulation principles, I think, in object-oriented programming, and that principle basically, suggests that your classes should be directly responsible for their states, and therefore the states should be protected by classes, and this is done by declaring data attributes private. But another part of encapsulation is that the responsibilities which materialize in form of these methods, right? An ability to carry on certain tasks, accomplish certain behaviors, is also part of encapsulation, because the set code, is present here in this class and not somewhere else. So encapsulation suggests also, besides just keeping things private and public, is that which class is responsible for what behavior in our system.